Hi, I'm Diasha. Before we begin today's lesson, let's recap what we have learned so far in this series. We have discovered that when an acid and an alkali react together, they neutralize each other. The products formed in this reaction are a salt and water. A salt is the substance that forms when the hydrogen ion of an acid is displaced by a metal ion. This means that every acid forms a different type of salt. Remember this relationship? Hydrochloric acid gives us chlorides. Nitric acid gives us nitrates. Sulfuric acid gives us sulfates. And vinegar or acetic acid gives us acetates. Now, so far, we have 3 different methods for making salts. We can write these as general equations. An acid plus an alkali react to form salt plus water. An acid plus a carbonate react to form salt plus carbon dioxide plus water. An acid plus a base react to form salt plus water. Remember that all metal oxides are called bases. Now, you may have noticed that the reaction between an acid and an alkali gives the same result as an acid and a base. Are there any differences between these reactions? Well, that's the focus of today's lesson. We are going to be making salts by reacting acids and different metal oxides. Let's take a look at today's outcomes. By the end of this lesson, you will be able to identify the reagents required to prepare a particular salt and write balanced chemical equations for preparing salts. Even though an alkali and a base are similar, there is an important difference. Can you remember what an alkali is? That's right, an alkali is a soluble base. We form alkalis when oxides of group 1 metal oxides dissolve in water. These metal oxides then form hydroxides. All of these group 1 metal hydroxides are strong bases. There's one other example of an alkali that you should know about. This is the solution formed when ammonia gas dissolves in water. Ammonia is very soluble in water, and the solution formed is basic. This means that a solution of ammonia is an alkali. It contains ammonium hydroxide. So, if I wanted to make the salt ammonium chloride, can you select the ingredients we would need? What reactants would you use to prepare ammonium chloride? I hope you have an answer. Now you can see if it is correct. When given a problem like this, I like to start by choosing a general equation. Here I have it. An acid plus an alkali react to form salt plus water. If we want to make ammonium chloride, the only acid that we can use is hydrochloric acid with the formula HCl. The alkali to use must be ammonium hydroxide with the formula NH4OH. Now, to get the salt, the hydrogen from the acid is donated to the alkali, and the ammonium from the alkali joins the anion of the acid. Our salt will therefore be NH4Cl. And now, to complete the equation, all I need to do is add in water as a product. Next, check that it is balanced. Count the number of each atoms present above and below the equation. Here I have 1 chlorine and here I have 1 chlorine. Next, 1 oxygen here and 1 oxygen here. Now for the hydrogen atoms. 1 plus 4 plus 1 gives us 6 hydrogen atoms. And below we have 4 plus 2, which is also 6. So this equation is balanced. Right, now that we understand that alkalis are soluble bases and only the group 1 metal oxides form strong alkalis, let's move on to look at other metal oxides. Group 2 metal oxides are partially soluble, but most of the other metal oxides are less soluble. These metal oxides will also neutralize an acid, but the process may take longer, or alternatively, we will need to adapt the method we use. Before we go to the lab, can you work out what we need if we want to make copper 2 sulfate? What reactants would you use to prepare copper 2 sulfate? In this case, the general equation is an acid plus a base react to form salt plus water. The acid we need is sulfuric acid, and the base we need is copper 2 oxide. So the word equation is copper 2 oxide plus sulfuric acid react to form copper 2 sulfate plus water. Let's go to the lab now to see what method John is using to make this salt.
Now I have my base here. It's black copper 2 oxide. Remember, this doesn't dissolve in water, so I can't do an acid plus an alkali experiment here, but I am going to add sulfuric acid to this base. Not much is happening. So I'm going to add some energy by heating it. Place it on the Bunsen burner, and let's leave it for a few moments. If you look carefully, you'll see the solution is starting to go blue. This indicates the presence of copper 2 plus ions, but there's still a lot of unreacted copper 2 oxide, which is the black stuff at the bottom. I'm going to filter this using this filter paper now. Here's the black copper 2 oxide that hasn't reacted. Coming out here at the bottom is the blue filtrate that contains our lovely copper salt. Copper 2 sulfate crystals are going to form in this evaporating dish. We'll have a look at those later.
Wow, wasn't that solution an amazing blue color? Now, did you manage to write the balanced equation? Check your answer now. Copper 2 oxide, which is CuO, plus sulfuric acid, H2SO4, react to form copper 2 sulfate, which is CuSO4, plus water, H2O. Notice in this reaction, the acid donates 2 hydrogen ions and the metal oxide accepts these to form water. So the metal oxide is acting as a base, according to the definition. An acid is a proton donor. A base is a proton acceptor. Notice that the copper ion replaces the hydrogen ions to form the salt. Let's take a look at today's task. How could you prepare copper 2 sulfate if you did not have copper 2 oxide? In our next lesson, we will return to the lab to look at the crystals formed from the reaction we did today. Until then, goodbye.